It's 4-4, graphing a function rule today. All right, so we know a function means 1x in, 1y out. So what is the graph of the function rule? Negative 2x plus 1. So we're not talking about this in slope-intercept form, which is something you could also do. We're going to substitute in some points, so then we can use that concept on other things. So let's just start with 0. 0 is a nice number to plug in. So when I plug in 0, then I'm doing negative 2 times 0 plus 1. Well, negative 2 times 0 is 0, and 0 plus 1 is 1. So when x is 0, y is 1. I can graph that point, 0, 1. All right, then I'm just going to go to 1, right? When I plug in 1, I'm doing negative 2 times 1 plus 1. So that's going to be negative 2 plus 1, which is negative 1. So when you plug in 1, you get out negative 1. So I go right 1, down 1. We're going to do at least 3 points, so I'm going to go to 2. I could go negative 1. There's no reason to do negatives in this one if I don't have to. So I've got 2, so I have negative 2 times 2 plus 1. Well, negative 2 times 2 is negative 4, and negative 4 plus 1 is negative 3. And what I'm writing just right there, I'm just showing you. Most of you can probably do that in your noggin. So we have 2, negative 3. So then we know it is going to be linear. It's in y equals mx plus b. So I can now use those points to make a line. Whee! I would have arrows on both ends to show that it goes forever, and there is my graph. Beauty miss. Let's try again. So we've got y equals 1/2 x minus 1. So same concept. I'm going to start with 0 because it's usually the easiest number to plug in. So 1/2 times 0 is 0, minus 1 is negative 1. So I've got the point 0, negative 1. So if you're wondering where those numbers came from, right now I'm just going to pick 1. You can use any numbers. I'm just staying close and small. So I do 1/2 times 1 minus 1. Well, 1/2 of 1 is a half. 1/2 minus 1 is negative 1/2. So when you plug in 1, you get out negative 1/2. So that's right 1, down negative 1/2. I'm going to go plug in 2. So that means I'm doing 1/2 times 2 minus 1. Well, half of 2 is 1. 1 minus 1 is 0. So we've got the point 2, 0. Oh, look at me. I graphed that last point wrong. So if we were in class, y'all would have been screaming at me, right? This should have been 1, negative 1/2. What am I doing? So I should have been at 1, negative 1/2. So now I can make my line. So there would be my line. Arrows on both ends to show that it goes forever in that situation. All right, but now we're going to go to the real world. And in the real world, it probably isn't going to go in both directions forever. So the function rule W equals 8g plus 700 represents the total weight W in pounds of a spa that contains g gallons of water. What is a reasonable graph of the function rule, given that the capacity of the spa is 250, right? So we have to think about actual possible answers this time. So based on the gallons, that's our independent, we're going to figure out what the weight is, which would be our dependent. So thinking of numbers I could plug in, the least amount of gallons I could put in a spa would be 0, right? I can't put in negative gallons into a spa. That doesn't make any sense. The most that I could plug into this spa, the capacity is 250. So the biggest is going to be 250. So then I want to do at least 3 points, so I'm going to pick something in between 0 and 250. And I wouldn't pick like 72.87, which is a possibility. Anything between 0 and 250 is a possibility. I would pick something pretty. So I'm going to go with 100. Right? So now when I plug in 0 into our function, we'd have 8 times 0 plus 700. Well, 8 times 0 is 0. 0 plus 700 is 700. So now I'm going to plug in 100. So that means I have 8 times 100, right? So 8 times 100 is 800. And then 800 plus 700 is 1,500. And then I'm going to plug in 250. So I'm doing 8 times 250. And then I would add to that 700. I'd probably use my calculator on that one. So 8 times 250 is 2,000 plus 700 is going to be 2,700, 2,700. All right, so I'm going to graph here. So down here on the bottom, I would have my gallons, right? Because that's my independent. My weight is going to be over here. I'm going to start at 0 and count by, I don't know. I'm going to make this 100. So I'm really counting by 25s. 1, 2, 3. This would be 200. Because I don't need to go over 300. So I can see my weight here. I have to go from 700 to 2,700. So maybe I'll count by 500s. So every other line I'm going to do 500. So 500, 1,000. This would be 1,500. I love writing with a mouse. It's so much fun. 2,000, 2,050. 3,000. There we go. Good enough. All right, so now I can plot my points. So I know when I have no gallons, it is 700. All right there. When I have 100 gallons, it weighs 1,500. And when I'm at 250 gallons, so 250 gallons, I'm at 2,700. All right, so when I connect these though, so I did 0, 100, and 250. I could have also done like 50, I could have done 172, right? Anything in between here. So this guy would have an endpoint on the left and an endpoint on the right because you cannot go any further to the left than 0, and you can't go any further to the right than 250. So this would go starting here, and it would have to end there. And then we'd have all of the gallons and weights in between. All right, so that leads us to a conversation of the difference between continuous and discrete. So continuous means that you have a situation where you can connect the dots, right? So we went from 0 to 250, but you could do every single number in between 0 and 250. So that's why we made a line and connected the dots. Discrete means that you cannot connect the dots, right? You cannot connect the dots. So let's say you're going to see a movie. You can buy 1 ticket, 2 tickets, 3 tickets, 4 tickets. You can't buy 2.5 tickets to go to the movies. So that's discrete. You would not connect the dots. So continuous means you connect the dots. Discrete means that you do not. So in the next one, we want to figure out, is this going to be continuous or discrete? Do we connect the dots or not? So the amount of water W in a wading pool in gallons depends on the amount of time, T, in minutes the wading pool has been filling, as related by the function rule W equals 3T. So we are doing, based on the time, right, how much water will you have, right? So again, first number, time is going to have to be, the least I could have is no time, right? And the most I could have, well, there's no end here, right? I could keep going forever and ever. So I'm going to say the most I'm going to spend is, I don't know, 30 minutes filling up my wading pool. So then I'm going to pick something in between. I'm going to go with a pretty 10 minutes. So I can't do negative minutes, so that's why I don't have any negative numbers here. So from 0, if I plug in 0, 3 times 0 is 0. When I plug in the 10, 10 times 3 is 30. When I plug in 30, 30 times 3 is 90. All right, so I'm going to go, I have my time on the independent. The amount of water is our dependent. I'm going to count by 5s. So I'm just going to label every other one. So 10, 20, 30. I'm going to count over here. I have to go from 0 to, I'm going to count by 10s, but I'm going to label every third one to make it by 30. So we've got 30, 60, 90. So I've got my points. If I spend no time, I've got no water, right? We've got 0, 0. If I spend 10 minutes, we're going to have 30 gallons. So 10, 30. If I spend 30 minutes, I'm going to have 90 gallons. So then I have to figure out, is this going to be continuous or discrete? Well, I went from 0 to 10. I could have spent 5 minutes. I could have spent 5.5 minutes. I could have spent 13 minutes. I could do all of the fractions and decimals and integers here in between. So I can't go past 0. So I would have my, oh, I forgot to pick the line. I'm going to have an endpoint on the left, but it's going to go to the right. It's going to keep going. Now, how far is it going to keep going? I don't know. It's going to overflow. But since I can connect all of the fractions and decimals in between, this one would be continuous, right? This situation is continuous because I can connect the dots. Oh, look at that. It's still doing it. That's funny. All right, whereas in this next situation, the cost for baseball tickets in dollars depends on the number n of tickets bought, as related by the function rule C equals 16n. So we are doing, based on the number of tickets, what is the cost? So the least amount of tickets I could buy is 0. I can't have a negative amount of tickets. The most is going to depend on how much money I have, right? So let's say I buy 0 tickets, then I buy 5 tickets, then I buy 10 tickets. So if I buy 0 tickets, well, 0 times 16, it costs me no money. If I buy 5 tickets, well, 16 times 5 means I'm going to spend $80. And if I buy 10 tickets, 16 times 10 would be $160. All right, so I'm going to have my number of tickets down here. My cost is my dependent up here. I'm going to count by 1. So 1, 2, 3, 4. I'm just going to label every fifth. 6, 7, 8, 9, 10. Over here, I'm going to count by tens. I'm not going to take the time to label them all, but I'm going to count by tens. So now I have my points. If I buy no tickets, I spend no dollars. If I buy 5 tickets, I'm at $80. 10, 20, 30, 40, 50, 60, 70, 80. And if I buy 10 tickets, I'm at $160. 90, 100, 1, 2, 3, 4. Just a little bit off the chart. All right, so now let's talk about connecting the dots or not. Well, I can buy 0 tickets, I can buy 5 tickets, I can buy in between 1, 2, 3, or 4 tickets, but I can't buy 1.5 or 2.7, so I cannot connect all of those dots. So that means that this is discrete. This is a discrete situation because you cannot connect all of the dots in between. There are some points in there in between that you could connect, but you cannot connect all of them, so it makes it discrete. All right, so lesson for today, if you can connect all the dots in between your 2 points, it is continuous and you would make it a line. If you cannot connect all the dots, every single one of them in between, then you do not connect the dots, and that is called discrete.